first member is an element of set A and second member is an element of set B is called the Cartesian product. So the set of first elements of the Cartesian product is A and set of all second elements of the Cartesian product is B. So therefore A is equal to A and B, whereas B is equal to X and Y. A cross B intersection A cross C is 1, 4, 2, 4 and 3, 4. That's it. The common in these two sets. Hello dear students, welcome to this session of Mathematical and Statistical Computing. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding Unit 2. In Unit 2, we are going to study regarding relations and functions. Now let me discuss regarding the first part of the chapter, that is relations. So I am going to discuss regarding relations. For that, the very important concept is the Cartesian product. I am going to discuss regarding the relations. So here in this session, in relations, definition of a relation and types of relations and the problems related to relation. For that, let us know regarding the Cartesian product. Now, what is a Cartesian product? Suppose given two non-empty sets P and Q. Suppose if P and Q are any two non-empty sets, then the Cartesian product of P and Q is denoted as P into Q, that is P cross Q, is the set of all ordered pairs of elements from P to Q. Set of all ordered pair of elements from P to Q, and it is denoted as P into Q. P cross Q is equal to a set P comma Q such that P belongs to capital Q and Q belongs to capital Q. That means the first member is an element of first set and the second member is an element of second set. So that is, if A and B are any two sets, then the Cartesian product of A and B is denoted as A cross B is equal to X comma Y such that X belongs to A and Y belongs to B. That means first member is an element of set A and second member is an element of set B is called the Cartesian product. That is, the set of all ordered pairs denoted as A cross B is called the Cartesian product, in which X belongs to, that is, the first element belongs to A and the second element belongs to set B. Now, if either P or Q is the null set, then P into Q will also be an empty set and that is also a null set. If either P or Q is a null set, then the Cartesian product P cross Q is also a null set. For example, let us take an example. If A is equal to red, blue and B is nothing but B, C and S. How to write the Cartesian product A into B? First take red. So red and B, again red and C, again red and S. Similarly, blue and B, blue and C, blue and S. This is called the Cartesian product. So here P and this is Q. In P, what we have? Red, blue, then red and blue. Whereas in B, this is A, this is nothing but call it as A and this is B. In A, we have red, blue or P, red and blue. Whereas in B or Q, it is B, C and S. B, C and S. How to write? So, red to B, again red to C, again red to S, that is nothing but red comma B, then red comma C and red comma S, that is red B, red C and red S. Similarly from blue, that is blue to B, blue to C and blue to S. So blue to B, blue to C and blue to S. This is how we are going to write the Cartesian product of two sets A and B or P and Q. Now, let us take one example. Let me write one example. If A is equal to 1, 2 and B is equal to A, B, then the Cartesian product from A to B is denoted as A cross B is equal to, so let us take the first element 1, A, again 1, B. Similarly, the second element 2, A and 2, B. 2, A and 2, B. So this is the Cartesian product from A to B. Suppose if you want to write B to A, Other hand, the Cartesian product B cross A, B into A is denoted as first elements are the elements of set B, A comma 1 and A comma 2. Then B comma 1, B comma 1 and B comma 2. This is the Cartesian product from B to A. So here the first elements are the elements of the set B and the second elements are the elements of the set A, right? A into B and B into A. Now let us take a problem like this. If x plus 1 comma y minus 2 is equal to 3 comma 1, find the values of x and y. Just by equality equate it. So this is equal to 3 and this is equal to 1. That is x plus 1 is equal to 3 and y minus 2 is equal to 1. So what is x? X is equal to, transfer plus 1 to the right hand side, it becomes minus 1. X is equal to 2 and y is equal to 1 plus 2, that is equal to 3. So therefore x comma y is equal to 2 comma 3. Right. Now move on to the next problem. Similar type problem. If x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, find the values of x and y. Same, equate it. X by 3 plus 1 is equal to 5 by 3. Y minus 2 by 3 is equal to 1 by 3. Now here x by 3 is equal to 5 by 3 minus 1. Take LCM. This is same. 3 is the LCM. 5 minus 3 ones are 3. This is equal to 2 by 3. 3 gets cancelled. Therefore x is equal to 2. X is equal to 2. Here, so y is equal to 1 by 3. Transfer minus 2 by 3 becomes plus 2 by 3. Take LCM. 3 is LCM. 3 gets cancelled. 1 plus 2. This is 3 by 3 is equal to 1. So y is equal to 1. Therefore x comma y is equal to 2 comma 1. 2 comma 1. X is equal to 2 and y is equal to 1. That's it. Right. Now move on to the next problem. If P is equal to A, B, C and Q is equal to R, then from the set find P cross Q and Q cross P, or these two products are equal. So verify, just find out P cross Q and Q cross P and verify whether they are equal or not. So here, what is P into Q? The Cartesian product from P to Q is P contains A, B, C, Q contains only one element R. So this is A comma R, then B comma R and C comma R. This is Cartesian product from P to Q, P cross Q. Again Q cross P. So here this first element is R, R comma A, again R comma B and R comma C. What do you say from these two? Here the second element is R, 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 whereas here the first element is R, R, R. So they are not equal. So P into Q is not equal to Q into P. They are not equal. These two products are not equal. Now, move on to the next one. This is an important type problem. You may expect this type of question for 2 or 5 marks. Let A is equal to 1, 2, 3, B is equal to 3, 4, C is equal to 4, 5, 6. Find A cross B intersection C, and the second one is A cross B intersection A cross C. For the first one, just find out B intersection C. B intersection C means the common in B and C. What are the common elements? 3 is not here. Here only one element is common, that is 4 is a common element. Now first one, A cross B intersection C. So just write down the Cartesian product for A and B intersection C. That is 1 comma 4, 1 comma 4, 2 comma 4 and 3 comma 4. This is the Cartesian product for the first one, A cross B intersection C. And the second one, for the second one, just find out A cross B first, the Cartesian product of A and B. So A contains 1, 2, 3, B contains 3 comma 4, 1 comma 3, again 1 comma 4. Then 2 comma 3, 2 comma 4, then 3 comma 3 comma 3, 3 comma 3 and 3 comma 4. This is Cartesian product of A cross B. And find out Cartesian product of A and C. A and C contains A and C. That is 1 comma 4, then 1 comma 5, then 1 comma 6. Similarly, the second element is 2, 2 comma 4, 2 comma 5 and 2 comma 6. Then 3, 3 comma 4, 3 comma 5 and 3 comma 6. Now, these two are connected by the disjunction. Now, the disjunction for this, I'll put disjunction here. These two are connected by the intersection. So, A cross B intersection A cross C. The intersection is nothing but the common. So, what is the common here? So, we have 1 comma 3. Here 1 comma 3 is not there. 1 comma 4, 1 comma 4, we can take 1 comma 4. Then 2 comma 3 is here. We don't have 2 comma 3. 2 comma 4, 2 comma 4, 2 comma 4. This is common. Then 3 comma 3 is there. 3 comma 3 is not there. 3 comma 4 and 3 comma 4. This is the intersection. So, A cross B intersection A cross C is 1 comma 4, 2 comma 4 and 3 comma 4. That's it. The common in these two sets. Now, move on to the next one. Same in this. Just find out A cross B union C. First write down B union C. B union C. The union of B and C is 3, 4, 5, 6 is nothing but 3, 4, 5, 6. 3, 4, 5, 6. Right. Now, A cross B union C. That is nothing but what is A contains? A contains 1, 2, 3. 1, 2, 3 into 3, 4, 5, 6. Write down the Cartesian product for this. That's it. So, what is this equal to? 1 comma 3, 1 comma 4, 1 comma 5 and 1 comma 6. Similarly, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. Again 3 from 3, 3 comma 3, 3 comma 4, 3 comma 5 and 3 comma 6. This is the first answer, right? Now, the second one, A cross B union A cross C. So, that is A cross B. What is A cross B? The cross product of A and B. What is A contains? A contains 1, 2, 3. 1, 2, 3 into B. What is B? B contains 3 comma 4. So, this is equal to 1 comma 3, 1 comma 4. Again 2 comma 3, 2 comma 4. Again 3 comma 3, 3 comma 4. Right. Next, A intersection C. A intersection C. A cross C. What is A? A contains 1, 2, 3. Cross product of C. A is 1, 2, 3. Cross C. What is C contains? C contains 4, 5, 6. So, 4, 5, 6. Now, what is this equal to? 1 comma 4, 1 comma 5, 1 comma 6. Again 2, 2 comma 4, 2 comma 5, 2 comma 6 from 3, 3 comma 4, 3 comma 5, 3 comma 6. Now, what is given? Union of these two. We have to find the union of this. Just combine this. So, therefore, this is equal to, first write down the first one, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, 3 comma 3, 3 comma 4. So, 1 comma 4, here 1 comma 4, 1 comma 4 cancel, gets, so 1 comma 5 is not there, you can write 1 comma 5. Then 1 comma 6, we have not taken 1 comma 6, you can write 1 comma 6 here, 1 comma 6, again 2 comma 4 is taken, then 2 comma 5 we have not taken, 2 comma 5, then 2 comma 6 we have not taken 2 comma 6, so 2 comma 6, then 3 comma 4, 3 comma 4 is also not here, 3 comma 4, again 3 comma 5, 3 comma 5 is not taken, take 3 and 5, 3 comma 5 and 3 comma 6. So, we have not taken 3 comma 6. So, this is the union. So this is the union of A cross B union A cross C. Hope you followed. That's it. Just find out A cross B and A cross C, just combine, and repetition is taken only one time. That's it. Now move on to the next problem. If A is equal to -1, 1, find A into A into A. This is the triplet. So here first find out A into A. What is A? -1, 1, cross product, again -1, 1. Just write down the Cartesian product for this. -1, -1, -1, +1. Again from 1, 1, -1, 1, 1. Now for triplet, just A into A into A. So for this, just multiply with A. For this, another A. That is, what is another A? -1, 1. That's it. So this is equal to -1, -1, -1. Again -1, 1 and -1. Again 1, -1 and -1. Again 1, 1 and -1. Now take the second element. Same. Here it is -1, -1 and +1. -1, 1 and +1. Again 1, -1 and +1. Again 1, 1 and +1. This is called the triplet. A into A into B. That's it. Now the next one. If A into B is equal to, Cartesian product is given. If A into B is equal to A comma X, A comma Y, B comma X, B comma Y, find A and B. So what is A and B? A is nothing but set of all first elements of the Cartesian product. That is, A and B is A. Whereas B is nothing but set of all second elements. That is nothing but X comma Y. That's it. So the set of first elements of the Cartesian product is A and set of all second elements of the Cartesian product is B. So therefore A is equal to A and B, whereas B is equal to X and Y. Now same type problem. If A is equal to 1, 2 and B is equal to 3, 4, verify A into B. How many subsets will be from A to B? First find out A into B. A into B. So A into B is nothing but 1, 3, 1, 4. Then 2, 3 and 2, 4. This is the Cartesian product, A into B. Okay. So here, since A cross B contains, A cross B is equal to 1, 2, 3, 4. So therefore the number of subsets, the number of, how many subsets will be from A to B? Number of subsets from A cross B is nothing but 2 to the power of this, call it as M. So 2 to the power of M, that is nothing but 2 to the power of 4. What is 2 to the power of 4? 2 to the 4, 4 to the 8 to the 16. So there are 16 subsets from A to A cross B. Right. Followed. See what is given? A cross B is equal to 1, 3, 1, 4, 2, 3 and 2, 4. So therefore number of A cross B, N of A cross B is equal to 4. That is nothing but M. Number of subsets are nothing but 2 to the power of M, that is 2 to the power of 4 is 16. Now move on to the next problem. Next concept, relation. Now relation. So the first part is regarding the Cartesian product. The second part is the relation. Now what is the relation? A relation is nothing but the subset of the Cartesian product A cross B. That's it. A relation or from a non-empty set A to non-empty set B is a subset of the Cartesian product of set A and set B. That is, R is the subset of A cross B. A relation is a subset of the Cartesian product A into B. So if A and B are any two non-empty sets, then the relation is the subset of A cross B, denoted as R is the subset of A cross B. The subset is derived by the describing a relationship between the first element and the second element of the ordered pairs A into B. The second element is called the image of the first element. The second element is the image for the first element. The second element is called the image of first element. Now let us know regarding the domain, range and codomain. What is a domain? The set of all first elements of the relation is called the domain. The set of all first elements of the relation is called the domain of R. The set of all second elements of the relation is called the range. Range is nothing but the second element. So the set of first elements of the relation is the domain. The set of second elements of the relation is called the range, and the codomain is nothing but the complete second set is called the codomain. The complete second set of the relation R is called the codomain. Now let us take for example, in this example, if A is equal to A, B, C is the domain, then range is apple, ant, ball and cat, then the codomain is nothing but apple, ant, ball, cat and dog, the set B. Right. Now let us take an example. Let A is equal to 1, 2, 3, 4, 5, 6. Define a relation R from A to A given by R is equal to x comma y such that y is equal to x plus 1. Depict this relation using an arrow diagram. Write down the domain, codomain and range for this. Now first find out the relation. So what is given here? R is equal to x comma y such that y is equal to x plus 1 means x is x itself, y is equal to x plus 1. Take the values of x as 1, 2, 3, 4. When x is equal to 1, y is equal to 1 plus 1 is 2. So the first element is 1 comma 2. So I'll write the relation here. R is equal to 1 comma 2. When x is equal to 2, y is equal to 2 plus 1, that is equal to 3. 2 comma 3. When x is equal to 3, y is equal to 3 plus 1 is 4. So this is 3 comma 4. Next, when x is equal to 4, x is equal to 4, y is equal to 4 plus 1, this is equal to 5. This is nothing but 4 comma 5. Right. When x is equal to 5, when x is equal to 5, y is equal to 5 plus 1 is 6. So this is 5 comma 6. Okay. Whereas when x is equal to 6, y is equal to 6 plus 1, 7. This does not belongs to the given set A. So we cannot take 7 because 7 does not belongs to A. So therefore, because the relation is from A to A. So therefore, the relation R is equal to 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5 and 5 comma 6. The first part. Depict this relation using an arrow diagram. So arrow diagram. A contains 1, 2, 3, 4, 5, 6. B contains 1, 2, 3, 4, 5 and 6. Right. Now what is the relation? 1 to 2, 1 to 2, again 2 to 3, again 3 to 4, again 4 to 5, 5 to 6. This is called an arrow diagram, a relation from A to A. Now what is the second part? Write down the domain, codomain and range. So domain of R. Domain of R. Domain is nothing but the set of all first elements of the relation. Set of all first element is 1, 2, 3, 4 and 5. This is the domain. Right. What is the range? Range of the relation. Set of all second elements of the relation. What are the second elements? 2, 3, 4, 5 and 6. Right. So range is 1, 2, 3, 4, 5. Set of all first elements of the relation. The domain of R is the set of all first elements of the relation. That is 1, 2, 3, 4, 5. What is the range? Range is the set of all second elements of the relation. 2, 3, 4, 5, 6. Then what is the codomain? So domain, range. Now codomain. Codomain of R is nothing but the set A itself. That is A is 1, 2, 3, 4, 5 and 6. So this is the codomain. Right. Domain, codomain and the range. This is very important type of problem. Now move on to the next problem. Let A is equal to 1 comma 2, B is equal to 3 comma 4. Find the number of relations from A to B. So here same. First write down A cross B. The Cartesian product of A and B is 1 comma 3, 1 comma 4, 2 comma 3 and 2 comma 4. Right. So n of A cross B. Number of elements in A cross B is 4. So therefore the number of relations from A to B is equal to, So the number of relations from A to B is nothing but 2 to the power of m into n, that is 2 to the power of 4, that's equal to 16. So the number of relations from A to B is 2 to the power of m into n, that is nothing but 2 to the power of number of elements in the Cartesian product A cross B, that is 2 power 4 is 16, that's it. Now move on to the next problem. So here if A is equal to 1, 2, 3, 4 etc. up to 14, define a relation R from A to A by R is equal to x comma y such that 3x minus y is equal to 0, where xy belongs to A. Write down its domain, codomain and range. First write down R. What is the given condition? Here this is given x comma y is nothing but x as it is. What is this 3x minus y is equal to 0 means y is equal to 3x, that's all. So multiples of 3. So therefore the relation R is equal to, when x is equal to 1, y is equal to 3 into 1 is 3. When x is equal to 2, y is equal to 3 into 2 is 6. When x is equal to 3, y is equal to 3 into 3 is 9. When x is equal to 4, y is equal to 3 into 4 is 12. When x is equal to 5, y is equal to 3 into 5, that's equal to 15. But 15 does not belong to the given set A. So these are the values of R. So the relation R contains 1, 3, 2, 6, 3, 9 and 4, 12. Now write down one by one. Now first what is to write? Write down the domain. Domain of R is equal to set of all first elements of the relation, that is 1, 2, 3 and 4. This is the domain of R. Then second one, range. Range of R is equal to set of all second elements, that is 3, 6, 9 and 12. Okay, the third one is nothing but the codomain. Codomain of R is nothing but the set A itself. All the elements from 1 to 14. That's it. Okay. Move on to the next problem. This is an important problem. Determine the domain and range of the relation R defined by R is equal to x comma x plus y such that x belongs to 0, 1, 2, 3, 4 and 5. So here what is given? X belongs to the set of elements 0, 1, 2, 3, 4 and 5. Now we have to write the relation. So what is the relation? X comma x plus 5. Right. So when x is equal to 0, 0 plus 5. 0 plus 5 is 5. Right. When x is equal to 1, 1 plus 5. 1 plus 5 is 6. 1 comma 6. When x is equal to 2, 2 plus 5, that's equal to 7. 2 comma 7. When x is equal to 3, 3 plus 5, it is 8. Right. When x is equal to 4, 4 plus 5, it is 9. When x is equal to 5, 5 plus 5. 5 plus 5 is 10. That's it. So the last element is 5. So when x is equal to 5, x plus y, second element is 10. So therefore, the relation R is equal to 0 comma 5, 1 comma 6, 2 comma 7, 3 comma 8, 4 comma 9 and 5 comma 10. Here the elements which belongs to x belongs to 0, 1, 2, 3, 4, 5. The second elements 5, 6, 7, 8, 9 and 10. So therefore, what is the domain here? The domain of R, domain of the relation R is equal to set of all first elements, that is 0, 1, 2, 3, 4 and 5. This is called the domain. And what is the range? Range of R. Range of R. Range of R is equal to set of all second elements of the relation, that is 5, then 6, 7, 8, 9 and 10. These are the domain and range for the given problem. Hope you followed. So these are few problems related to Cartesian product and the relation and finding the domain and the range of the function. Hope you followed. This type of problems are very important for the point of examination. You may expect 1 or 2 questions for 2 marks and 5 marks. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.